is Algebra 2 intervals, average rate of change, and difference quotient today. So we're going to start off with warm-up on function notation because it leads to help with the difference quotient. We've kind of been building up our skills using function notations so that we can get to do this difference quotient today. So they want f of a negative 3m. That means wherever you see x and f, you need to replace it with negative 3m. So, by the way, identify what you are doing. Communicate that you are plugging a negative 3m into the function f. And then use an equal sign and replace the x with that negative 3m. So I want communication to be clear on that. And then drop down, don't go left to right, drop down, start with an equal sign. And then simplify it. And that's as good as it's going to get, and so box your final answer. So part of the math is to communicate, what you're doing and box your final answer. That needs to all be part of what you have there. All right, and then in this example 1, given g of x, so we have x's here, here, and here, but we want x to be 2t plus 1. So we're going to substitute that 2t plus 1 in for x. So that quantity is going to have to be squared here, because x is squared. Then we're going to take 2 times the quantity. And don't forget the adding 1. That's something that can be missed. Now, when you square 2t plus 1, when you have that 2t plus 1 and you square it, you should end up with a trinomial. The common error is to just square the beginning and square the end, and that is not true. The square of that is not a 2-term binomial. It is a trinomial. What you need to be doing, is taking 2t plus 1 times 2t plus 1. You distribute your 2, the 2t, you distribute your 1. And when you square a binomial, the middle two terms are always the same. And it ends up looking like this. So the square of a binomial is a trinomial. And you have to do the powers first before you multiply by 4. So you need to do that squaring, and this becomes that 4t squared plus 4t plus 1. Squaring comes before multiplication, and then distribute the 2. Notice that as I drop down, I'm starting with an equal sign. You should as well. And you should be going down the paper, not left to right. That's 20t. There we go. 16 4t plus 7. And box your final answer. You're going to be doing something similar to that in our difference quotient today. By the way, there's a fun kind of little saying that another teacher that used to teach here previous to me came up for squaring a binomial. And so this first term in the binomial comes from 2t times 2t. So square the 2t. That'll give you this. Square the 1 gives you the end term. So it's square it. But then the middle two terms, you get 2 of them to get this. So it's the product of these 2, but it's doubled. So multiply and double it. So the saying goes, square it, multiply and double it. Square it, multiply and double it. Just a little thing to remember. It. Square it, multiply and double it. So it's square the beginning, goes out front, square the end, goes in the back. Multiply the 2, but double that, goes in the middle. Square it, multiply and double it. It's just kind of fun. So if that helps, awesome. All right, next we have rate of change. And that is actually going to be the average rate of change. The average rate of change. And when you have the average rate of change, it is simply slope. Average rate of change is simply slope, meaning that you're going to need 2 points. And I want you to write them down. And then substitute into the slope formula. So the slope formula, you have x sub 1, y sub 1. Just to review, you have x sub 2, y sub 2. And the slope is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. It is your change in y. So it is the y coordinate minus the y coordinate. And that goes in the top. And once you go from this point to this point, that direction, you have to do the same in the denominator, x sub 2 minus x sub 1. You've got to go in the same order or you're going to get the wrong sign. You can get positive when it should be negative and vice versa. Now, let's go ahead and do this, and it's just going to be a little bit more abstract. Right here, this is A, so we're going to come up here. And so instead of having a value like 2 or 3 or 5, the value is A. So we need to plug A in for x. And so the x coordinate is A, the y coordinate is f of A. That's the best as we can do because we don't have the equation, it's just expressed as f of x. How do you like that? A little bit abstract there. And then we have b over here. So, go up. Here's the point. The x coordinate of that is b. And then again, we have to plug that b in for x. So the y coordinate is f of b. And so the slope, you are going to be taking the y coordinate, and I'm going to let this point with b be the y sub 2, x sub 2, y sub 2. And so take f of b minus the f of a, and that goes in top. And then the b minus the a is going to go in the denominator. So f of b minus f of a all over b minus a. It's simply slope. What you are finding is the slope of the line through those 2 points. You're finding the slope of the line through those 2 points. And when you look at this, usually along the bottom when we do rate of change, the x-axis is dealing with time and the y-axis is dealing with, it could be a lot of things. It could be distance, it could be volume, it could be temperature. And as time change, there's, whatever the y-axis is, distance or volume or temperature, it's changing. But in this case, for this change in x from here to here, it only goes up this little bit. So its rate of change isn't as fast as it is, woohoo, yeah, okay, from here to here. When x changes from here to here, y goes from here to here. So it's going up a lot more quickly on the last half than it does on the first half of that interval. And so it goes slow, but then it speeds up. The slope of the line between those 2 points gives you your average rate. Your average rate. So it's kind of like if you were going to walk from this point to this point, you could, it's the same distance. This is the same distance. You could start off slower and then start speeding up and go a lot faster. And say that took a second. Instead, you could just go at a constant rate of change. That takes a second. I cover the same distance. It's just the average rate of change. That's kind of what's happening. You can get the same result of increasing or going this distance by going slower to begin with and faster at the end, or you can just walk at a constant rate and get the same distance for the same amount of time. Anyways, that's coming up. Just some things to get in your head for, AP pre-calc and calc. All right, so this leads to what we call the difference quotient. So the difference quotient. And we're going to have function f of x, but we are going to start with x. And then instead of giving the point over here a different variable, well, it is a different variable, but what we're going to do is we're going to add the distance of h to x. This process is helpful when we get to the limiting process in calculus. Right now we're doing average rate of change, which is simply slope. But you do a limiting process in calculus that gets you to the instantaneous rate of change. What is my rate of change right now? And so using this idea that x plus h is h units away from x, this helps that process. Well, if those are my two x values, then my ordered pair here is x f of x. And then if I go up here, my x value is x plus h, and then I have to plug that into the function to get the y value. And now we have our two ordered pairs. That's what you need, the 2 points. There's my 2 points. Now we're going to take y sub 2 minus y sub 1 in the numerator. It looks like that. And then in the denominator, we're going to take x sub 2 minus x sub 1. But what always happens with these is that x's cancel out. So we can simplify this. To just be over h. And that is the difference quotient. That is my difference quotient. Yay. So all that work with function notation has been leading to being able to handle this difference quotient. So find the rate of change, which is really the average rate of change over the following intervals. This always messes people up because I want the average rate of change on the interval from -2 to 0. These are both x values. It's not an xy ordered pair. These are both x values. So on the number line, or on the graph, we're going from -2 to when x is 0, and I want to know the average rate of change. Average rate of change is simply slope. What does Mrs. Remington want? 2 ordered pairs. My first ordered pair starts with x being -2. And the y value when x is -2 is 4. So I want you to write those ordered pairs down that you're using for slope. So for the x sub 2, the x is 0, and when x is 0, the y value is 0. So we're using the point -2,4 and the point 0, 0, and you're going to find the slope of the line that goes through those 2 points. That's your average rate of change on that interval. And so label it as slope. Now I am going to let the first point be my x sub 2, y sub 2, just because immediately I go, I'd rather take 4 minus 0 in the numerator than 0 minus 4. You get the same answer either way you do it if you do it correctly. But change in y. So I am thinking of this y minus this y. So in the denominator, I'm going to take this x minus this x. So in the denominator, I have a minus 2 minus 0, and that simplifies to a negative 2. That's my average rate of change. And it should make sense because that line goes down as you go from left to right. It's decreasing, the slope's negative. Repeat the process on the others just to try and figure this out a little bit. So x sub 1, this is x sub 2. So my first ordered pair starts with 0. My second ordered pair starts with 3. These are x values. So I'm looking at the point 0, 0 and the point 3, 9. I'm finding the slope of the line between those 2 points. So it's 0, 0 and 3, 9. Slope is 9 minus 0 over 3 minus 0, and that's going to simplify to 3. Any questions so far? Seem pretty straightforward? The key is remembering to study this for the test, because all of a sudden people forget that these are both x values. And they're going, you only gave me 1 point. How can I get slope if I only have 1 point? So you've got to remember to study those kinds of things. So just real quickly then, this is x sub 1, this is x sub 2, so negative 2, and then 3. So instead, on the graph, we are using negative 2, 4, and 3, 9, and we're finding, the slope of the line between those points. So negative 2, 4, and 3, 9. And slope is change in y over change in x, 3 minus a negative 2. You get 5 over 5, which is 1. Now, some people, I've seen people use the graph to get slope, which is it's not a bad process. So people are going for this run, this is the rise. So what is rise over, what is rise over run? And they figure out this is 5 and this is 5. And that's all the work they show. I want this work. I want you to list the points and use the slope formula, not just do it on the graph, please. Okay, so next page. This is asking for the average rate of change, example 3. And this is another understood to be an interval, but the information is given to you different. They didn't give you a graph with the points already labeled on there. They just gave you the function. This is still my x sub 1, and this is my y, and this is my x sub 2. These are both x values. So I need, when x is 1, what is the y value? When you have the equation, you plug the 1 into the function to get the y value. On the previous example, they already had done that for you. You have to do the work here. And then you want this ending when x is 3, so you need to plug the 3 into the function to get the y value. So I'm just going to do that off to the side here. Label what I'm doing. H of 1 equals, plug in 1 for x, and that comes out to 2. Plug in 3 for x, now, order of operation makes a difference. You need to square this You need to square this 3 first, then multiply by 3. Power is coming from multiplication. I've seen some people multiply those and square that, getting 81. No, that's the wrong thing. Square that is 9 times 3 is 27. Subtract 1, and you have 26. So I want those ordered pairs listed. So you've got 1, 2, and you've got 3, 26. You've communicated clearly over here the process to finding y. And then we can label this as slope. And we get the change in y over the change in x. And that becomes 24 over 2. And when I run out of room vertically, I show an arrow to indicate this is, as to indicate to whoever's reading this where we're going next. And you get 12, and then box that as my final answer. There's a lot going on there. You got work over to the left and the right, and, tell me what is my final conclusion here. That is my average rate of change. So starting with concrete examples, example 2, values in terms of finding average rate of change. Now we're going to move to the difference quotient, which is still average rate of change. We got it by getting slope, but we're going to have we can have some variables in our end answer. Example 4, find the domain range and evaluate the difference quotient. Find the domain and range. Well, I didn't give you a graph. Well, for this first one, you should understand that this is a linear function, and it's oblique, meaning it has a slope that's not 0 or undefined. It's not a vertical or horizontal. It's slanted. Oblique it's a slanted line. The slope of this thing is 3. So knowing properties of the lines, you should go, domain, since it's going to be all reals, and range is going to be all reals. Worst case scenario, you put it into the graphing calculator at desmos.com and see what it looks like. I'm hoping most people know that this is a line with a slope of 3 and can figure out domain and range. Now for the difference quotient, I'm going to need f of x plus h to put in the top. So I need f of x plus h. So in here for the function f of x, I need x plus h. So it's going to be 3 times the quantity x plus h minus 2. I'm also going to need f of x. I'm going to subtract from f of x plus h. I'm going to subtract f of x. So that f of x is just the function 3x minus 2. So I'm going to calculate the difference quotient. And I need to start with that f of x plus h. What does that equal? All of this. So I'm going to plug that in to start the numerator. And that is your f of x plus h. But then I need to subtract from that f of x, which is this entire quantity over here. And you need to subtract the entire quantity, so that f of x needs to be in parentheses. We're subtracting it. We're going to have to distribute that negative. And it is all over h. So what I've got going for me so far is this whole expression is your f of x plus h. And this is my f of x. And I'm subtracting those. And then do the math. 3x plus 3h. Don't forget that minus 2 there. Now distribute the negative, meaning both the signs are going to change. It's going to become a minus 3x, but a plus 2. And it is all over h. Now some things cancel. This 2 is going to cancel out this negative 2. This minus 3x is going to cancel out this positive 3x. And the only thing left is going to be 3h. So 3x cancels that. By the way, when you're canceling these, I still want to see what it was originally. So, do a nice little cancel, but I should be able to see whether it was positive or negative. What it was shouldn't get lost visually for me to be able to see if you had it. Oops, I didn't want to do that. And then the -2 cancels. So I can still read what it was before I canceled. And then I'm out of room vertically, so I'm going to come up here and start a new column. I'm going to start with an equal sign. And I like the fraction bar centered with the equal. And I want to see the step where you write what is left after canceling in the numerator over h. I want to see that step. And then the h's cancel, and you end up with 3. Unique with linear functions is that note that the slope of this line was 3 to begin with, right? The slope of that line, mx plus b, is 3. The difference quotient is taking 2 points on the function, drawing a line through them, and finding the slope of that line. Well, when you take 2 points on a linear function, you draw the line, you're drawing the actual line. The slope is what the slope of the line is. So we should know that it should come out to 3. But you're practicing the algebra, and this is a simpler problem to do the algebra on to start with. So you're trying to practice the difference quotient and trying to learn what you're doing with it. So it shouldn't be surprising that it comes out to 3. Now, in example 5, we're changing to a quadratic function. Excuse me. And number 5, it's quadratic. Now, if you don't know what this looks like, type it into, go to desmos.com, calculate, and choose a graphing calculator and plug in 2x squared plus 3 and see what it looks like. But you've been taught parabolas before. The 2 being positive means it opens up. There's no x term, so this plus 3 just has it shift up 3. And so the graph of this is going to go 1, 2, 3. That's going to be the lowest point, and it's going to be a parabola opening up. Since there's no x term, it hasn't shifted right or left any. It's a polynomial, and the domain of polynomials is always all reals. It's a polynomial. For the range, the lowest point is 3, and then it just goes up, 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 up from there. All right, for the difference quotient, you're going to need f of x plus h, which is going to be 2 quantity x plus h squared plus 3. That is going to be what you're plugging in for this part right there. That is this function where you replace x with x plus h. And then you're going to need f of x. And f of x is the 2x squared plus 3. That is what you're plugging in for f of x. So in the difference quotient, we're going to have this 2x plus h squared plus 3. That is your f of x plus h. And subtract from it the entire quantity, 2x squared plus 3. And all of that is going to be over h. So this is your f of x plus h. And this is your f of x. You're taking f of x plus h minus f of x. Then we're going to drop down, have an, not that far. Have an equal sign, have your fraction bar centered with your equal sign. Communication. That squaring of the x plus h, can we use our little saying? Square it, multiply and double it. Square the x, square the h, which goes at the end, multiply, which is xh, and double that is 2xh. Square it, multiply and double it. You have to do that squaring before you multiply by the 2. Powers come before multiplication. And then subtract f of x, meaning you have to distribute that negative. You get a minus 2x squared and a minus 3 all over h. Now distribute that 2. And then we have some things that are going to cancel. The 3's will cancel. The 2x squared with the minus 2x squared will cancel. Anything that does not have an h should cancel. If it doesn't, you've made an error someplace. The only thing that's left in the numerator has h's in it, and I expect that. So I'm going to drop down, center my fraction with the equal bar, and write what was left after cancellation. Now, to cancel out the h, you need to take the h out of the first term and one of the h's out of the second. We're going to take one, factor out an h, and then we can cancel the h's. It has to come out of both terms. And so I'm kind of out of room, so I'm going to have an arrow, write my fraction bar, and I'm taking an h out of the first term, leaves me with 4x. Taking one h out of the second leaves me with plus 2h, and it's all over h. That's factoring out h. Now, those h's cancel, and my end answer for the difference quotient is this. You don't get a single numerical value. And I just want, conceptually, if I take any 2 points, so if you look up at the graph for a sec, if I pick a point here and a point here, the slope of that line is not the same as if I pick a point here and a point here and draw that line. And so the slope is dependent on which points you're picking. So we don't get a numerical value for slope. We have a varying slope. And it depends on the interval that you're picking. So that should be expected with a quadratic, because any 2 points, if you connect a line, you get different slope values. All right, and then this last one is your first, well, actually, you guys got to see, I believe yesterday, just one that came out to be linear. Now this one's a little bit more involved, where they give you pieces of information and you need to draw the graph given these pieces of information. And it's a puzzle. And you have to take into play, okay, this characteristic, and then you get a third, oh, that what I drew doesn't fit, and you have to start and kind of resketch. It's a layering effect. So I have a domain of -1 to 4. So -1 is here, 1, 2, 3, 4 is here. The -1 has to be solid, and the 4 is not included. So between vertical lines at -1 and 4, the entire function has to fit. It doesn't get any wider than that. The range is from -1 to 8. The -1, it has to have an ordered pair where the y-coordinate is -1. It goes up to 8, but it's going to be an open circle because 8's not included in the range. So between those two horizontal lines, the function has to be drawn. All right, and then we have increasing and decreasing. And so for increasing and decreasing, we have 1 to 4. It's increasing. I'm just going to draw an arrow that's saying it's going up between x values of 1 and 4. It's decreasing -1 to 1. It's going down from -1 to 1. So it starts and it goes down and then it goes up, and that's the only change that occurs. So it starts up, it goes down, and it goes back up. It has x-intercepts of 0 and 2. Those points you can't change them. We all have to have those. And then it is positive from -1 to 0. It is positive. It is above the graph. It is also positive from 2 to 4. And it's negative from 0 to 2. So it's got to be below the graph from 0 to 2. So our final answer can vary. But it's got to be negative between 0 and 2. And it has to be decreasing from the start all the way to where x is 1. So I'm thinking it's got to hit this value of -1. So I'm thinking it comes down, hits negative, it's decreasing, going back up. It's negative in there. It has to start by decreasing. And on the left, it can't be higher than 8. It could be anywhere in here. As long as it starts on the vertical line, -1, that could be looking different for different people. But it can't go to the left of -1, and it can't go higher than 8. And then it keeps increasing after 1 and it has to go as high as 8. So there's a possibility. There are other things that could work. And that's the nature of it, is you just have to keep puzzling it out till you get something. You go back and you start reading, is my domain, is my range right? Am I increasing, decreasing right? You go back and read the list over and over to make sure that it fits everything. And that's it.